Well, hi. Thank you again for joining me here in my shop. I continue on with this radio. Very mysterious radio. So, hey, let's just go over the mysteries quickly. One mystery is, what is this tube socket all about? Another mystery is, how come it says battery operated radio down here, yet this radio comes with a plug for the wall? I have a schematic for this radio which appears to match it, except it doesn't. So we're going to look at that a little bit closer, and I'm going to raise the question here: does this thing even have the correct tubes in it? I have encountered this before, where I've presented a radio with the wrong tubes in it and wrong tubes in the wrong place, and so that's possible here, because the schematic talks about a different set of tubes. But I think as we look at this a little closer, we might come up with a story that's a little bit more believable than the one I have in my head, which is, the story I have in my head is that Bill, back at the radio factory, was causing a lot of trouble, so the manager there said, why don't you just send Bill to the back room and make him put nameplates on chassis. He can't cause any problem there. And so off went Bill into the back room to put nameplates on, and somehow he managed to put on the battery nameplate onto this radio, which is actually not a battery radio, never was, right from day one. I think this radio came out of the factory looking just like this. I don't think this has been converted after coming out of the factory. So what makes me think all these weird things about this radio? Well, let's take a look at a photograph of it here. Okay, so this is the, right now we're on a website called Radio Museum. I'm a member of Radio Museum. I encourage anybody who's into doing this work to join Radio Museum, become a member, and start providing information to this international public database, which is really fantastic. So my hat's off to the people who got this going and keep it going. So anyway, that's exactly what my radio looks like in terms of the cabinet. Look, it even has the same little bit of ratty cloth in here as mine. Whereas I'm missing the glass, I'm missing some knobs, especially this circular one on the outside here I'm missing. Too bad. But look, we get some pictures of the inside of the radio here too. Look, tube. Now let's compare these photographs, the radio to the real radio. The photograph I want to work with is this one. So let me get that set up here. Okay, so now you're looking at the radio and a photograph of the radio. Now, just look at that for a moment, you're going to spot a big difference. Okay, so in the photograph you see a big can in this area. You see a big metal can. I'm going to guess inside that can is the vibrator and whatever else is necessary power supply wise to make that a battery operated radio. But you see in the radio I have, there is no can. Instead there's a great big honking transformer and a rectifier tube right here. So my guess is the Bill story really isn't true about this. My guess is they had a bunch of these chassis ready to go, and somebody came in, somebody from the sales department came into the engineering department and said, stop the battery operated radios, stop them, they don't sell anymore. We have to be able to plug our radios into the wall. So they quickly took this existing design with a pile of half-built chassis, figured out how to put in a power supply. In doing that, this is my story, the engineers also changed the tube lineup in the radio, for the most part. That's my guess. That's my story on this. So it kind of explains the power supply quite nicely. Why they wouldn't bother changing this? It's probably all just cost issues, and probably they said nobody cares about this plaque anyway. Once it's on there, it's on there. We'll leave it on there. Or they didn't want to make up more plaques that said no battery radio or whatever. Who knows? who knows really how this ended up with a plaque. I think of this radio as a little bit like a one of those stamps, you know, a postage stamp, where, you know, the little boat is upside down on the stamp or something, and the stamp is now worth, you know, $10,000 because of an error on it. Maybe it's true of this radio. a plug-in radio with a sticker on the back that says it's a battery-operated one. It's worth millions. Okay, so let's look at this end of the deal here. In the photograph, you can see there's two tubes in there. If you look closely, it's a little hard to look closely. That's about the point of my computer screen, but you can't see me do that. You know what? You can see me do that. That's kind of weird. Okay, so you can see me point now. So if you look at this tube closely in the photograph, it looks like a two-part tube. It looks like it has two halves. I mean, it's hard to tell in the photograph. According to the schematic, this tube should be a two-part output tube meant to drive push-pull. Wait a minute. How can that be? Where's the push-pull transformer? There's no audio transformer in this radio. So there's a combination of things going on here now. It's got me thinking. Let's go back to the radio here. It's got me thinking. 4 wires when only 2 are necessary. Transformer up here. This may not be the original speaker. This may not. It may be the original speaker in the sense that it's the one that was, you know, included with the radio when it was sold. But based on the earlier schematic of the battery-operated version, this may not be the same speaker. You have the same tubes. It's not the same supply. Why would it be the same speaker? Why would they maintain 4 wires? I don't know. I haven't got that part figured out. But it's just possible that on the original one, can I point kind of toward the original one? That tube, this tube is a double tube and does drive a push-pull type transformer that's mounted right on the speaker. Not this one, but maybe the speaker that was intended with the battery radio. So a double tube here, and a center tap transformer up here, lots of wires going to it to achieve that. Why not mount the transformer here? Now look at, okay, now there's nothing on the photograph. There's nothing in here either, but curiously enough, there's a cat in here. Can you see him? This cat gets around in the dark. You never know where it is. So maybe there was something here, or intended to be here, and maybe this is where the push-pull output transformer was mounted. I don't know. It doesn't appear in the photograph. Maybe there's 2 or 3 versions of this radio. Maybe there's more than one version of this thing. Okay, comparing more in the photograph, everything else looks really very identical when I look at it. All this wiring up in here, all this stuff, all looks identical. All back here. Look, I got these screws here. They appear in the photograph too. This is the same. Things start looking different when you look at the tubes. Now, you can't necessarily know just by looking at the shape of a tube whether it's the same or not, because things change over time. But this is a 6K7, and the tube in the photograph in the same position does not look like a 6K7, but I can't be sure. Same thing here. In the photograph, you can see the grid cap is a big one. And interestingly enough, the grid cap here, although it's missing the plastic part, maybe it was never on it, this is meant for a large post. Now this tube and this tube are the same tube, 6K7. This one has a small post. This one has a large post on the top. That in itself is pretty weird. From what I can see inside the tubes, they look the same. But that's kind of weird, isn't it? And it just so happens that this is large and this is small. Are those tubes really for sure the same? 6K7. I can read it right on it. And then this one's written on the base, which I remember seeing. 6K7. Maybe they were marketed with two sizes of grid cap on the top. I don't know. Another thing that you can't see in the photograph is another tube down here. You can't even see it in the video right now. If I just turn this a bit, you'll see it. There it is. Grid cap wire coming to the center here. And we look at the photograph closely. Yeah, I can see a wire coming down from here just the same way. It's not just us who are studying this. There's somebody else studying all this stuff too. Ever wonder why stuff disappears out of my shop? I think I know why. So what is all this telling me? So I looked on the chassis before I turned the video on. I came running in here last night after seeing this photograph, and I looked at this photograph early on, but I did not look close enough at it to recognize the differences. So I came running in here last night, all excited, and I looked for evidence of the can, original can, being down here, mounted down onto the chassis. I figured we'd be able to see it. If the can was ever here, we would see it. There's no evidence that there was ever any can here at all. So I think we can be quite sure this thing came out of the factory just the way it is. So that's the situation. And I didn't really dwell on this. Let's dwell on this a little bit. So in this radio, there are wires coming to this position sufficient to fire up the heater. I'm wondering what... There's some funny sounds on the video right now. It's because the cat is toying with the microphone over here. just while I'm looking at it, you can see both my microphones in view here right now. This one is a stereo microphone. That's the one you listen to me mostly on. That's the one you're listening to me mostly on. But when I turn to face my video screen and keyboard, I have another microphone here that picks up my voice. It's just the left channel, I think, right now. Okay, thank you for that little side story. Oh man alive, something bad's gonna happen. I gotta get it on video. You know what? I gotta get you down because you're too much. You're too much. Come, don't pin yourself up there like that. Oh, come on. This is the cats are curious. This one certainly is. Okay, it doesn't like being held. That's Mr. Independent, Mrs. Independent, Miss Independent. It's a girl cat. Okay, going back to this thing. So it's got two wires coming to it sufficient to fire up the heater on the tube that was in there. The tube that was, this is just so weird, the tube that was in there electrically is the same as this older tube, but the pin arrangement is different. But otherwise it's electrically the same. A 6F6 versus a 42. So, one immediate possibility is, well, you had your choice. You could run it with this or run it with that. But you need a lot more wires coming to the socket that aren't there now. So there were wires coming to it. They're all cut away. So why did they leave the heater hooked up here? Why would they do that? And then there's some odd resistors between pins, which I didn't really explore that, but it looks like it's wired up for something. For a few moments there I thought, oh, it's wired up for a magic eye, but there's no magic eye in here, and this is not wired for a magic eye. It's not wired for anything except to turn the heater on. It's really mysterious. I thought about, well, maybe this is an input for the battery supply, but we now know the battery supply was a big can over here. The battery power supply. So I don't know what this is. Now looking in the photograph again, there is a tube sitting in there. For all I know, it's just as bogus as this radio. I kind of doubt it though. What I had thought, I mean, this tube is located close to the output, so we could think this through. This guy here is a pretty busy tube, and he's detector tube and first audio amplifier. He's got a lot going on in there. So he sends a signal over to here and goes out to the speakers. It could be in the previous version this was not as busy a tube. This may have been a detector only tube, and then the detected output is sent to a preamp just sitting here, and then the preamp is feeding into here. Now that's most likely the case. You know what? There's going to be a tube listing on this website. We can find out what tube that supposedly is. Maybe. Let's look and see. 15, 6A8, 6Q7. So see, 6C5 is not in this radio at all. 19 and 15, I don't even know what those are. I still don't know what those are. The 19 is this tube here. The 15s, the two 15s in here are where you find the 6K7s. And this is the same, and this is the same. And of course the output tube is a 42. Quite different from this. So I think this tube here, must be a 15. 15 because I'm not sure. I don't know what a 15 is. If that's a 15, wait a minute, that's a 15 and there's another one in here. Okay, so there's none of this. This can't be. There's no grid cap. So this 15, let's see, grid cap, everywhere but here. I lost my train of thought there. That's too bad. I was on to something. I was zooming in quick on something. I know what I'm zooming in on. So if there's two 15s, then there should be two identical tubes in this radio. We can't see the one back here, but there's a grid capped tube back here. All the rest of these I know what they are, except for this one. So this has to be the other 15. But there's no grid cap, and there's no facility for a grid cap to reach this tube. I don't know. Obviously, I'm not getting this right. I think it's just a mystery that's going to remain. What a weird situation, man alive. Okay, let's get on to doing something with the radio itself now. Okay, and what am I going to do with this radio today? We could do a little signal tracing again, and this time start at the front end and try to work our way this way. What I seem to have found, and question marks everywhere, is that the audio portion of the radio is working okay. From the detector forward, the detector is getting no signal from the rest of the radio, or very, very low signal. I think it was the last thing I was kind of concluding. So we could listen to what's reaching the top of these tubes here, the three of them here. We could listen to that and see what that tells us. I don't have to think too much harder about it. Okay, you can see the yellow wire here is just a junky wire antenna laying haphazardly behind me. Okay, get on the signal tracer and get it ready. Will it reach? Yep. ready on the power here. Yep. I've had this running at around 95 volts AC. Seems to run not much different than when you put it full voltage. So I'm keeping it on the low. I'm keeping the dim lights in the circuit here, so it continues to run with less input power than it's designed for. Okay, let me have a listen here. Okay, there's a nice hum coming out of there. Okay, let me close my door. So that seemed to be stone quiet there the other day. And I found that the AM band appears to be shut down. So are we on the AM band? No. We're on the AM band now. Okay, 3 bands didn't make any difference. So I'm set, there's 3 band positions on the switch. I think it's AM shortwave, shortwave. I'm set to the middle one now, shortwave. Volume control is set where? That's a tough control to turn. Okay, it's full. I'm going to turn it back just a little bit. Okay, let's listen. Now, we're trying to hear RF signals from a grid here. As soon as I touch this, it kind of disrupts the circuit quite a bit. And I don't know yet which one's AM, which one's shortwave. I haven't been able to figure that out because the radio's dead. So I should have my signal tracer. I'm going to set it. I mean, it can only do so much. So this is set for RF. And it's just set for the AM radio band. I'll poke around enough, maybe we'll figure something out. That's kind of my theory in life, you know. Okay, volume, hand on volume here. Wow. Doesn't get any quieter than that, eh? Oh. Man, I mean, usually you can't really touch anything, can you? Anything. How come I can touch this? Nothing. Okay, let's try the next one here. Stone silence. How can that really be? How can that really be? Go on. Just like a cat. Just kind of ruining her fun there, I think. I was just reading that distractions like that have a terrible effect on people like me. Okay, let's go back to this. Nothing. How can there be no signal there at all? Nothing. How many times am I going to say nothing? It's my other favorite word, okay and nothing. Let's try tuning, band switching. Okay, try again. I think something's wrong here. So we're back on what I think is shortwave high. What was that? That was my signal tracer making that sound. So I would expect there to be noise at those points, even if the radio's switched off. But I touch the antenna. So that's what's being fed into the. That's what's being fed into the radio. Goes through some coils, I think. How much want to bet it goes straight to that broken coil, the one that I'm trying. The one that I'm trying to fix the lead on. It's probably still not working. Still far-fetched that these are stone silent here. Far-fetched. It's the truth, Jim. It's not far-fetched. Okay, hand on the volume control here. So we would expect here for there to be a signal. I think it was 462. So let's go looking for that. Remember, the oscillator tube in that radio was bad. Okay, it was weak. That'd be the word for it. Okay, so I've switched the signal tracer to this upper scale. This is for picking up the intermediate frequency in radios. Most are 455. This one was it's written on here 462. So we'll dial this to 462, 450, 462. This is pretty accurate. Tuner, so that's 462. This is one dead puppy. Well, I'm going to flip the radio up so we can get into the back of it. I'm going to follow this until it disappears. Maybe we'll end up at that coil. Okay, so let me power off. That off. Trying not to reach under the chassis with my fingers. If you do this kind of stuff long enough, you get a pretty healthy fear of getting a shock. I'll leave it like that. There's the coil in question. Now, I shouldn't even need to put the radio on to trace this a certain distance. So starting with the antenna wire, I saw it yesterday, it comes in here. Did I do this yesterday and I was left with all kinds of weird feelings? So the set's not on. I can plunge in there pretty good with my tools here. Give me a flashlight. Okay, I can see where the terminal is. I just touch the terminal. Not like that, I can't. Right in here. Come on. We should hear. We hear nothing. Volume's down. We should hear loud sounds. There we go. Okay, so that boot was the other end of the antenna. Comes into this coil. Now I should be able to find it coming out on at least one lead. How many leads are there? Oh my gosh, there's quite a few. stuck in there. Let's see where we can find this. There. 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 Okay, we find it everywhere. What do we actually find it? Okay, antenna off. Yeah. Okay, I'm fooled. I think I'm hearing a signal coming in from the antenna. I'm not. There are diagrams of these coils in here. Fairly good diagrams down in this area. Red spot, white spot, blue spot, yellow spot. Really? Can we spot the spot in there? Let's take a look with a close-up camera. Spot the spot. Okay, I'll fix the focus here in a second. Spot the spot. There's a spot in there, supposedly. Could be a little bit of paint on one of the terminals, could be down on the coil. Spot the spot. Could be up in behind this thing here and we can't see it. So this thing, by the way, this piece up here, there are two adjustable capacitors. There. I think they're capacitors. They must be, yeah. And there. So that's interesting. These are the capacitors that tune the coils that are up here. You know, with a lot of these coils, especially IF coils, they do this. Let me rotate this around here. Can I do it? Excuse me here while we fly around. Okay, so they do that. They put holes in the top, and down inside are just some screws to adjust capacitors that trim the coil inside here. This one, they have, sorry about the focus here, let me just, there we are. This one, the trimming capacitors are outside on here. You can get at them through holes in the chassis up above to turn that screw right there. So there's a set there, and a set in behind here. And look at this coil, by the way. This guy. This looks like an antenna coil to me. Let's see. He's hooked up to more trimmers all along here. So this is quite likely the coil for the local oscillator in the radio. 1, 2, maybe 3 bands shown in it. Ooh. Not the most stable arrangement there, right? If this is actually the oscillator coil, then me moving those wires would throw this off. You know, shaking this radio hard would move those wires ever so slightly and throw it off. Now that's an interesting observation. Never thought about that. Never thought of that as a problem in a radio. Now, we're looking at coils. So I got this coil, the one that I'm having, I think, trouble with. And I got this other coil back in there. I see they're in the same sort of position physically in the radio. You have the band switch running through here. These are the wafers on the band switch. Then you have this section here. I have this section here. Both have coils in them. So I'm willing to bet there's a lot of coils in here. One of these is going to be for the AM band, and the other one is going to be for both shortwave bands. Which is which, you know, and I really can't guess which is which. I can certainly see how the circuitry flows up past the switch, or through the switch, up into this area separately. And from there, the signal having come through here or through here, you know, if that's really the case, if it's through here or through here, then I change the band switch. I can select which one of these coils the radio's relying on. Ooh. Oh my gosh, another broken wire here. Huh. There we go, man. No, it's not broken. It's just very dark right in there. It looks broken. Okay, don't fiddle with it, Jim, or it will be broken. Here you can see that coil. It looks like it's got 1, 2, 3. 3 windings on it. This one is just 1 winding. So I may be interpreting this completely wrong. Anything else worth looking at in here? Is there any more coils? I guess I'll get them all in my head here at this point. I don't think so. There's the this one over here, this one here, that guy there, and then of course up on top we've got, from underneath anyway, 1, 2, 3. The third one's over here. 3. 3. 3. Is it like band 1, band 2, band 3? We'll look at where this one's connected and see if it's somehow different from these other two. Sure looks like the same kind of layout generally. So always look at the schematic and kind of sort this out too, which we will do next. So it would be easy to find out if the oscillator is oscillating in this radio by sniffing this coil with the SDR radio and seeing what's going on. So that can be done. I'm a little dry for ideas here. Oh, you may not be. What to do now? And we poke at all these terminals in here with the signal tracer, and just hear what we hear. And then what about this third section? Okay, so this switch appears to be really entangled with this coil. So we're going to guess, as you switch bands, you are switching coils to select different local oscillator frequencies based on this switch. Now, these two are doing front-end switching, selecting either, this is what I believe, either this or this. Maybe not. Maybe one's flowing through the other. Okay, sounds like schematic time. Okay, I'm just going to hold this up in front of the camera here, see how this goes. So here's a whole whack of coils here. There's a whole set here and a whole set here. These really look like the oscillator coils. Then we have the 2 IF coils. We can forget about these. We can forget about those. Here we see 2 trimmers. No trimmer down here. Here we see 2 trimmers and no trimmer down here. This quite a complicated arrangement here. The antenna comes in, not complicated, the antenna comes in, goes through this coil, goes through that coil, goes to ground. Except there's a little feedback, not feedback, feed forward. Oh, that's the ground connection. That's all that is, okay. Yeah, you can't feed past the ground connection. So basically the antenna energizes a coil, and that coil, as a transformer, energizes some of these and then feeds on into the radio. Very typical. What happened to me looking for the colors? I forgot to finish looking for the colors there. Yellow spot. Well, maybe we can find it on the oscillator coil and prove that out. There's a red spot there. There's a red spot. Red spot. Blue, white, red spot. RF coil. So, okay, RF coil. Then these two diagrams have the same heading above them. Bottom view of coils. Oh, you know what? That's a standard title for all four of them. RF coil. I think it says detect coil. Let's get this on the screen here so we can look more closely at it. Bear with me a moment. Okay, here we are. So we can look down in here. Bottom view of coils, RF coil. This gives the part number there. Red spot. So that coil I was saying was the oscillator. Turns out to be an RF coil. Doesn't say much more. Over here it says oscillator coil, yellow spot. These ones, blue and white. Bottom view of coils. Detect coil. Oscillator coil. Well, I got it all wrong, don't I? So, these diagrams, are they laid out in accordance with this in some way? Like, this coil's here, and this coil's here, and this coil's here, and this coil's over here. Does it? Broadcast, police band, short wave. So that's how this radio thinks of these bands. Police band is just above the AM radio band. So the lower part of the short wave band. It's called the police band. Not anymore though, of course. Short wave. Same thing over here. Broadcast, police, short wave. And same thing here. Broadcast, police, short wave. Okay. That might be helpful. Broadcast has no trim. Broadcast has no trim. Broadcast is trimmed here. Wow, could be these two trimmers. I trim the high and the low end of the oscillator range. 1, 2, 3, 4, and then up here is just 1. Kind of a series parallel situation with these capacitors, so they do very different things. So let's see if we can't find this the oscillator coils. 60443, 60443, oscillator coil, blue spot. Okay, let's go spot the blue spot. Spot the blue spot. For goodness sakes, they're going to put this where it's quite visible. Would they? Is this a manufacturing issue? They're trying to prevent people from booping up during manufacture? Or is this for troubleshooting later, like I'm doing now? Okay, so I think I see a blue. I think I see a blue spot. It's not there. It's over here. This would be the location on the radio makes sense to me. Can you see the blue spot? Doesn't look very blue. I think the blue spot is right there. Where? Right. A little tiny dot right there. You're looking at the shiny thing is the actual blue dot, but you can't see blue in the camera. It's blue. So if I were going to put dots now, I'd put them all in the same place. In fact, see how this one here, I mean, it's right there in your face. You can't miss it. I would do the same with these. But the first one is kind of shoved up in here. The rest would be in the same place. That's what I would do. Aha! Okay, so I see some paint. You're looking right at it now. It looks like shiny aluminum paint. Way back up in there. But to me it looks yellowish. Oh, this is great. Here's a red one. Here's a red one. That's red. That's red. Oh my God, come on. You can't be doing this. I think the coil form is red. Here. It's great they do these things to make repairs easy. Okay, I gotta take this off here. Hang on 1 second. I gotta freehand my camera. See, my frustration level's going up. I can feel it. Let me change the focus a little bit closer yet. Hang on a second. Okay, let's try that. Let's start here. So there's the red one. Is there any question that that's a red dot? And then we look up in here. There's blue. Okay, now you see the color. Blue. You notice it's put in the 12 o'clock position in accordance to how I have the camera. Blue. Great. Okay, we'll go to the next one over. So you can kind of see it there. Having some trouble getting the light to hit it. There. Well, almost. Well, kind of a yellowy thing. Is there a yellow in this list? Is there a yellow? Okay, hold it right there. Let me check. Quick check here. Is there a yellow? A yellow. There's a white. Oh, so that would be the white. Oh my God, there is a yellow. Red, white, blue, yellow. Red, white, blue, yellow. You know, I gotta show you this on the, hang on. Oh boy, oh boy, oh boy, oh boy, let me tell you. Red spot, white spot, blue spot. Spots up here. Why? Why has this one got a spot up here? Oscillator POL. Oscillator police coil. Oscillator police coil. Oscillator coil. Detector coil. So what are they saying here? Just the police band on here? And then this right. it's not adding up at all to me. But the main thing is red, white, blue, yellow. Yellow and white may look the same at this point. Oh man, here we go again. I mean, there's other ways to figure this out, but I thought might as well use the dots. Hey, that'd be easy. That's how they're supposed to be done. It's really hard to see up exactly where I need to see. Okay, so now that really looks like red paint on there. And I have the camera upside down now, so that is actually the top of the coil form. Oh, sorry, I kind of lost it here. The camera's upside down, it gets a little harder to manage. So, okay, so red, white, blue, and yellow, that's got to be red. Red, white, blue, yellow. Oh, maybe that isn't a paint dot. Maybe there's another. Maybe there's something else on this coil. Maybe there's something yellow on it. Maybe it's not. It's pretty hard to deny that that's a red. And it's pretty hard to deny that this thing is red also. Okay, so according to the schematic here, I'm looking at it. The red is an RF coil. Okay, let's look at it this way now. Well, you know, wow. I think this stuff would just be so easy to figure out with some certainty. Certainty is what we really want to have in this. So based on the layout of the radio, this has got to be RF. This has got to be RF. Oscillator could be happening in here. Could be happening here. I got these two coils here. I haven't really identified where these two coils are in the schematic. So this coil is hooked up to this wafer, and this coil is hooked up to this wafer. We should be able to spot it that way. Okay, back to the schematic we go. So here's the switch. 1, 2, there's 3 sections here. What does it say there? It actually says what it is. Front view wave change switch. Switch is shown in short wave position, which I guess is not the police band. Yeah, because the way they are listed here, short wave, police, and broadcast. So the switches are shown for short wave. Okay. Switch number 5. Switch number 1. Switch number 1, switch number 2, switch number 5, switch number 4, switch number 5, switch number 6. Interesting how they numbered them. If we look at this switch, which is switching the oscillator coil, you're probably picking off either side, either end of these coils, or something like that. That didn't make sense what I said, but that's okay. You're selecting this coil, and then you are selecting this coil and this coil. That's how the switch is working. has to be a fairly separate switch the way they've shown it, because this side is doing something electrically very different from this side over here. They can't be wired together as such. So see how the switch is very separate. You can really see it in this diagram. And then the way they've numbered them helps too. 5 and 6. So this is 5 and this is 5. That's a little confusing to me, to be honest with you. Let's go again. 1, 2. This is 3. This is 3. It's just drawn to 3 lousy. 1, 2, 3, 4, 5, 6. Okay, everything's straight now. Got it all straight. So we're looking for those two different kind of coils. So we can kind of bet this is one of the ones in the can. There's 3 sets of coils in cans, along with 2 IF coils. So we're ignoring the IF coils. There's 3 big, tall cans on this guy, covering, got to be this coil, and it has to be covering these 2, because there's nothing else. Where's the other 2 coils? Well, this may be one here. It's got a separate number on it, part number 60457. This part number is 60441. So this coil is outside the can. So this is one of them. They're showing this inside the can. I'm sure it is. With this one outside the can, it can't be doing any resonance, any transformer action. It's just a coil. Wow, doesn't that sound familiar? Just a coil. That I think this is the one with the wire. If this is the one with the wire trouble, the wire either is connecting to earth, or to chassis rather, or the other side is going up. Might be a little tricky to trace it around, disappearing inside this can, and then coming out. It would be really tricky to trace that. I'll bet you it's either this wire or this wire that I'm having trouble with, right on the antenna circuit. That still leaves this other coil in here. I'm banking that the schematic is correct on the front end of this radio. It's really the audio circuits and the rest, but boy, that's a bit of a long shot, because if these tubes aren't what they say they are, if this isn't an RVC15 but in fact is a 6K7, then that calls into question just about all the wiring shown on here. Physically, in the construction of the radio, if they're going to make a change partway through a manufacturing run, they're going to change the little wires and parts in the radio. They're not going to change these big coils, because the chassis has been drilled out for them. They've ordered all these coils, or they've built them themselves. They have the cans, they have all this stuff. They won't fiddle with these coils. But what they would fiddle with, quite happily, is everything else. Everything else would get fiddled with. Different tubes, different resistors, different wiring, different capacitors, all the way through here. So does that explain why there appears to be one more coil in this radio than I can find on the schematic? And I really am just standing here staring at it, trying to find it. Could it be this thing? I just don't think so. They've shown this piece in line with these coils. Somehow these coils pick up a signal from the antenna. So this coil has to be within range of these ones. It's got to be inside the can. And this one could be outside. I'm pretty convinced now. This is the one I'm having trouble with. We could short this right out, and the radio might come to life. All I'm doing is detuning the antenna a bit. Who cares? I could short this guy out, and the radio might come to life. I'll show you the coil, just in case you're not sure what it is I'm trying to hunt for. I'll show you it. Okay, so I think this is the coil the antenna comes to. With just 2 wire leads to it. It's just a coil all by itself. This is the coil I seem to be having trouble finding. It's got, way down at the bottom there, it's got a big winding there, another winding just above it, and then 3, is that even 4? 3. I'm looking with my eyes, it looks like 3 separate coils on here. 1, 2, 3. 3 bands, 3 coils. There's no way to tune these, this thing, is there? Is there a... No, I don't think there's any way to trim it. I was going to listen to all these connections with the signal tracer. If this is in line with the antenna, I should be able to pick up antenna signal on one side of this coil, or leads coming to the coil. Okay, I got a little more in my head now. Let's go back to doing something with this. Power on. Antenna's not connected. Okay, we have the antenna connected for what it's worth. Just waiting for the radio to warm up a bit. Okay, I'll check the audio side of things. Okay. Signal tracer across all these coil points. Oh, this would be critical as to which band we're on. Well, we'll fiddle around, we'll find out. Okay, I'll set my signal tracer back to the AM radio frequency, which is totally wrong if we're actually trying to pick up shortwave. But as the antenna is switched through these coils, it should be able to hear some kind of change in this. Okay, hand on the volume control. Radio is on, antenna is connected. Volume is somewhere. Here we go. So one side is real noisy. Other side totally quiet. A little hard to believe. You could hear this on one side of a coil and hear this on the other side. Can't I poke right into the wire here? I mean, how well insulated is it? And there's something more wrong with that coil. Remember I talked about shorting this out. Just take it right out of the circuit. Now let's listen to this. Oh, band switch, band switch. Oh yeah. Yeah, that's what happens when you turn the on-off switch. Okay. Totally blown away there for a moment. This is the switch I want to turn. Okay. Quiet side stays quiet. Noisy side, noisy, but on only 2 settings. Assumably the shortwave settings. Shortwave feeding through this coil. Trying anyway. This coil. Starting the shortwave. Turn this up a little higher. There is something there. Band switch. Okay, these 2 positions quiet. only making sound in one position. So that would, you know, AM. Fortunately, it just doesn't work that way. There's 3 positions. 2 of them are shared, if you know what I mean. It's not like 2 short waves here and 1 AM there. It's not happening like that. It's like 2 short waves there and 1 short wave here. It's something like that. Something weird. It's not helping me. Not helping me sort this out. I want to get at the grid caps here. Okay, we're still listening to AM radio on the signal tracer. Oh, that's the on-off switch again. Huh? Quiet in 2. Sound in 1. Go to the other tube. Quiet in 2. Sound in the same one. Okay, let's try the top of the IF here. That's pretty darn quiet. Remember, we thought the oscillator may not be oscillating. Let's find that out. Let's find that out. This will take me a couple minutes to set up here. Okay, so what's up on the screen now is the SDR radio receiver's spectral display. See it change as I put my hand on this coil. I will now attempt to use this to pick up the local oscillator. Local oscillator, we can kind of zoom in on it. It's supposed to be in this area here. What did I say it was? 462. I'm stupid. Up here. 462. Somewhere. I'm going to set this red line here, this red line, onto 462. So we know exactly where it is. Okay, so the red line is marking 462 now up here. And we're going to try to pick up the local oscillator. The radio is on. Should be easy to pick up. I have found with experience that the local oscillator is very strong. When you do this kind of thing, all I got to do is tune the radio and the local oscillator should wander up and down in frequency. Tune the radio. So we're looking on the screen now for something walking back and forth. There's nothing happening there. Okay, the rest of the changes don't matter. It's just me moving my hand a little bit or something like that. Well, I don't see a thing. Okay, I think that's a shortwave band. I think that's a police band. I think that's the AM band. So now the local oscillator should be, well, it should always be this. No, it should be visible now. It wouldn't have been visible if that was shortwave before. I may not have this coil in the right spot either. Okay, so nothing where the red line is. Let me give it a little tune here. Nothing moving anywhere. Again, what I'm really talking about is on the lower part of this display, in this area here, the waterfall area, a line one of those lines should move around as I tune the radio. So now maybe it's really crazy. Let's just try some different locations here. See if we can pick anything up. Anything moving. Not seeing anything moving anywhere. So let me back up. I made a couple of misstatements. Okay, so we have the IF frequency, 465, should be able to pick it up. It's not going to vary. It's fixed at 462, in fact. 462.5. What I'm looking for is a local oscillator. Local oscillator should be that frequency, 462 kilohertz above the tuned spot on the dial. So that's actually more over in this area here. We'd expect to find a local oscillator wiggling around over here. Okay, I've got my head together now. I got my act together. So once again, we're going to attempt local oscillator movement. So this is really hinting there is no local oscillator. If there is no local oscillator, then there's no conversion to the IF frequency. There's nothing being fed into the front end of the IF circuits. There's nothing coming out the far end. That whole radio is quiet if the local oscillator is not oscillating. To be a little more sure here, I can get this around the back and wiggle it around some of those coils in the back. Okay, can we rotate this safely? To about there. Okay, I'll try this one up here. Doesn't seem to be much coming out of that at all. That's on the screen here. Again, if I'm on a short wave band, the local oscillator is way off the screen. I got to be on the AM band for this guy to work. So we're still guessing which band we're on. So I would guess that's the AM band there. We have this coil here. See nothing. And we have this coil down here, which we're pretty sure is a dud anyway. Nada. Kind of shove into these things here. See, I think they're taint. Well, we don't know what band we're on. We're trying. The AM band's not going to be in the middle. It's going to be on one end. So let's go here. Okay, and tune. Oh, bingo! There it is. Finally. Okay. What is it exactly? Okay, it's not this coil. It's that one. It's the one up in there. Is there anything coming out of this? Sometimes you can pick up this local oscillator all over the place, by the way. Let me move it again. I'm not picking it up. A little bit. There's noise coming out of the speaker. Volume is up full. I mean, that's not the best place to have it. Okay, last coil to poke around. Nothing here. Okay, so pretty convincing. The local oscillator is this coil here. Can I get this to sit in there? Probably not. Okay, okay, great. So we know the local oscillator is working on the AM band. We also know now the AM band is all this way. We'll go to the center band which could be either shortwave or police. The local oscillator has stopped at this frequency, but now it's up somewhere else. Who knows where? Who knows where? Who knows where? Okay, so if we're on the police band, it's somewhere up around 2.8, around 3. So we'll go up around 3 on here. We'll see if the local oscillator works on all frequencies. So we're going to go up to 3 megahertz here. There's a bright red line. Let's tune the radio. There, see it moving? Now that's the local oscillator for the police band. Okay. So that's working. Now the next. So this switch is actually backwards to what I would have imagined. So now we're on the highest shortwave band. The frequency we are tuned to is, judging from the pointer, looks like 7. So local oscillator is going to be within 465 of 7 megahertz. So we'll go up to 7. Let's see if I got this right. Okay, we're up around 7. There's a red line and a very strong signal. Right around 7.7. If I tune this, presto. Okay, so now we know the local oscillator is functioning in this radio. Even though the tube was weak, we know it's operating. Wow, is that all? That's about all I've succeeded in today. Yes. Finding out the local oscillator oscillates. So why no signal in the IF? Why no signal appears to, I don't know, why? Those are all questions. Those are all questions that need to be answered. So I think that's as far as I'm going to go today with it. That is one big step forward, knowing the local oscillator is functioning on all bands. Also finding out how the band switch actually works. So now I know where to go for AM for sure. That puts me in a much better position to poke around some more and keep going. Now some of you might be yelling out, well Jim, it's got bad capacitors. Of course it doesn't work. And you could be completely right. It could be a shorted capacitor in there that's deadening everything right in the front end. Or one that's open, it's not conveying anything anymore. Could be. Well, let's see if we can nail it down before I start changing out capacitors and introducing even more trouble into this radio. Okay, thanks again so much for watching, and I hope you're getting a kick out of this. This is the scary part of doing this work. You sort of walk into the forest and get lost really quick. So we have to spend some time stumbling around the forest until we get to know the lay of the land, and then all of a sudden we'll gain control over this whole troubleshooting process. So that's kind of how it works. Works for me that way anyway. Thanks a lot, and see you on the next video.